Hey guys, in this lesson I'm going to be looking at factoring binomials, special products. If you're following along in the book, this is from Algebra 1, Unit 6, Lesson 3. So remember, factoring is when you take a polynomial and you try and split it into smaller polynomials that are being multiplied together. And you should always look for a GCF first. Okay, there may or may not be one, but if there is one, you need to factor it out. Now, if you end up with a binomial, that means two terms, there's several different things that could happen. The first one is that it could be a difference of two squares, which we call dots. Difference of two squares, that looks like a perfect square minus a perfect square, so a squared minus b squared. So an example would be something like a squared minus 9, because that's a perfect square. X squared is a perfect square, minus, so that's a difference, 9 is also a perfect square. You could also get a sum of two squares, which looks almost exactly the same, but they're being added. So something like x squared plus 25. There's also difference of cubes, okay, which looks like a perfect cube minus a perfect cube. So something like y cubed minus 8. Or a sum of cubes, which is the same thing as difference, but you're adding. So something, let's say, like m cubed plus 27. So these are the four main special products. Now, a difference of two squares, a squared minus b squared, will factor into a plus b times a minus b. And you get a and b by taking the square root of a squared and the square root of b squared. So for our example here, we had x squared minus 9. Let me get a different color. I'm going to get two of these. One's going to be plus, one's going to be minus. The square root of x squared is x, so that goes in the front. The square root of 9 is 3, so that goes here. So that becomes x squared plus 3 times x squared minus 3. That's when it's a difference of two squares, a perfect square minus a perfect square. All right, now if it's a sum of two squares, it looks almost exactly the same, okay, except you're going to have an I in there. So a squared plus b squared, the only difference is this addition sign here, that factors into a plus bi times a minus bi. Okay. So in our example, x squared plus 25, and the only difference is this addition sign, but it makes a big difference. You have to remember to put these i's in. Okay. One's plus, one's minus. The square root of x squared is just x. The square root of 25 is 5, but since this is a sum, we have to put an I with those 5's. So we get x squared plus 5i times x minus 5i, and that's a sum of two squares. All right, difference of cubes. Okay. The formula for a difference of cubes is going to be a minus b, and I'm a little kind of out of room here, would be a squared plus 2ab plus b squared. Okay. Now, this looks a little confusing, so let's do an example here. So if we have y cubed minus 8, this is a difference of cubes. Okay. And guys, I'm sorry, I put a 2 here. There shouldn't be a 2. That's just plus AB. Okay. So what I'm going to do is take the cube root of y cubed and the cube root of 8. Well, the cube root of those, that's y and 2. So I'm going to get y minus 2 times, well, that's y squared, plus y times 2 is 2y, plus 2 squared is 4. So this will be our final answer here for a difference of cubes. All right, and then sum of cubes is exactly the same again, but you have an addition sign here, and it's going to be a plus b times a squared minus ab plus b squared. Now, the easiest way to remember this is the word soap. Okay? The first sign, this one, will always be the same as your expression, addition. The next sign, this one right here, is going to be the opposite sign. And then the last sign is always positive. So same, opposite, always positive. So if we have m cubed plus 27, the cube root of m cubed is m. The cube root of 27 is 3. So I'm going to get m plus 3 times m squared minus 3m plus 9. Notice it's the same sign first, plus, then the opposite sign, minus, is next, and then that last sign is always positive. So that's sum of cubes.